All right, to finish up factorial designs, we will review independent groups, within groups, and mixed factorial designs, and then both increasing the number of levels of an IV or an independent variable and increasing the number of independent variables. So independent groups factorial designs, both independent variables are studied as independent groups, which simply means we have different participants in our groups, so nobody is retested or there's no repeat measures. A 2x2 independent groups factorial design will have 4 groups or cells. A 2x3 will have 6, and so on. This is also, independent groups are also known as between subjects or between groups, because we are looking at the differences between different people or different groups. Nobody is being repeatedly measured to see a difference. Within groups, factorial designs are different in that we are measuring them at one point and then measuring them at another point, or measuring them on one independent variable and then measuring them again on a different independent variable, maybe a third independent variable, or a fourth, and then mixed designs are kind of right in between. So quickly, let me go over the pros and cons. So here is our independent groups design. Biggest con right here, we need different people. I don't know if you can see my cursor. If you cannot, I'm on this group, independent groups, all the way to the left. We need different people in each of our 4 groups. So we have neutral words and aggressive words. And then we have alcohol photo and photo. And I don't remember exactly, but I think they're looking at maybe like reaction time to something. So reaction times up here on the left are dependent variable. Our independent groups are photos and words. So we have 12 individuals here, neutral words, alcohol photo. 12 different individuals over here, neutral words, plant photo. Again, 12 different individuals, aggressive words and alcohol. And lastly, 12 more for aggressive words and plant photo. So over here, we're not going to have like testing fatigue, right? So they won't change responses based on, oh, I've done this before, or, oh, I know what the researcher is looking for. So that's one big pro. A great big con is we need a much larger sample size. Opposite of that is within groups, where the same people are tested in all conditions. So 12 people, neutral words, alcohol photo. Same 12 people, neutral words, plant. Same 12 aggressive words, alcohol, and same people, aggressive words, plant. And we are seeing how fast their reaction time is based on how they tested first here, then same group, how they tested here, third group, how they tested third time, and fourth time, right? So our great big con is that testing fatigue. Great big pro is we need a much smaller sample size. We only need 12. Mixed design is where we manipulate one independent variable and we simply measure another. And so this is a mixed methods design. If we are manipulating neutral words and aggressive words, we only need 24 participants. So 12 right here are in this neutral words and alcohol photo. A second set of 12 are in this neutral and plant photo. We then remeasure a second time, same group of 24 participants. Those who were in the neutral and alcohol photo are then retested in the aggressive and alcohol photo. Those who were in the neutral and plant photo are remeasured on aggressive and plant photo. And so our between subjects or between groups is right here, this neutral and alcohol and neutral and plant. Our within, so they're measured more than once, is neutral words and alcohol, and then aggressive words and alcohol, neutral words and plant, and aggressive words and plant. So we can take these as a whole. First right here they're measured, and then second with our aggressive and plant photo. Mixed factorial designs again quickly. One independent variable is manipulated, the other is manipulated as independent groups, the other is manipulated as within groups. Moving on to increasing the number of levels of an independent variable. So researchers can add more levels to their independent variables. Suppose the researchers in the cell phone and driver age, suppose they want to turn their 2x2 factorial design into a 2x3 factorial design by adding a third level to the cell phone condition. So maybe they look at handheld cell phone, hands-free cell phone, and no phone at all. They are not adding an independent variable, they are adding a level to their pre-existing variable. The variable, independent variable itself, is cell phone condition, and now they just have 1, 2, 3 levels of, where before they only have 1, 2. And then suppose over, so this is this one we're looking at right here, 1, 2, 3, and then they have their age 1, 2. This would change the number of cells up here, whereas before it would have just been 1, 2, 3, 4. Now it's 1, 2, 3, 4, 5, 6. So let me see, the number of blanks, so factorials are notated like blank times blank. The times is because we're looking at each one by the other. The number of blanks tells you the number of independent variables, and the numbers that you put in the blanks tells you the number of levels of each of the independent variables. So when we have a 2x2, the blank times blank, the blanks, if we have blank times blank times blank, that means we have 3 independent variables. So a blank times blank means we have 2 independent variables. Then the number we put inside there tells us the level. So 2x2, 2x3, 3x4. So over in right here, they have increased the number of levels on the age variable from 2 to 4. So now they have 4 groups, and they still have their 3 conditions. So now it is a 3 by 4 factorial design. We now have 12 cells. Main effects can still be calculated by using marginal means. So when we average out our numbers, right, and then look if there's a difference. So that's our main effects, but remember we're really interested in interactions. So main effects still calculated by using marginal means and seeing whether they are difference in the differences. Interactions are most easily detected with a line graph to see whether the lines are parallel. In both cases, always when we're doing these, statistical tests are needed to confirm whether the main effects and interactions are indeed statistically significant. Increasing the number of independent variables. Sometimes we need more than 2, or we're curious and we want to measure more than 2 independent variables. So again, on breaking onset, remember that's our dependent variable, that hasn't changed. But now we're curious if traffic affects, so if traffic affects our results, or if traffic has effect on the dependent variable, we're still looking at cell phone use and age of drivers. So now we have a 2 by 2 by 2 factorial design. Remember, the blanks are what let us know how many independent variables we have. So blank by blank by blank lets us know that there are 3 independent variables. Then the numbers in the blanks let us know the levels. So say we were still up here looking at our 4 age groups. We have like 20 through 29, 30 through 49, etc. Then we would have like a 2 by 2 by 4, or you could say a 2 by 4 by 2. That is just letting us know that in one of the independent variables we had more than, or we had 4 conditions. This is also called a 3-way design because there are 3 independent variables. It means there will be 8 cells. If you look at the table, all my emails are coming through. If you look at the table, you can see the best way to represent a 3 by 3 design is to create the 2 by 2 table twice. And then to create side by side graphs. We can see here light traffic has effect on our dependent variable. However, heavy traffic, it does not appear. We would count our marginal means. Does not appear that it does. I am going to talk about main effects and interactions from a 3-way design in another video quickly.